So this is 4-5, triangle congruent, side angle side, and side side side, SAS and SSS. Prior to this lesson, so in 4-4, 4-3, congruent triangles were defined as triangles with all angles and sides being congruent. So this was an example from, I think this was from 4-4, with all the corresponding parts, corresponding angles, and corresponding sides. These two triangles are congruent because every side matches another side, and every angle matches another angle, A to D, C to F, B to E, etc. So that made these triangles congruent. But there's actually shortcuts. We can show that a triangle is congruent. We can show a triangle is congruent without showing that all sides and all angles are congruent. And that's what we're going to do with this section. We're going to use two theorems to help us with that side, 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 and side, angle, side. So the first postulate that we're going to focus on is side, 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 abbreviated SSS. So side, 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 SSS congruence is our first postulate. So it does have a name, and we would just call it SSS. This is when every side is congruent to another side of a triangle, and so we can conclude that the triangles are actually congruent. If every side is congruent without even saying anything about the angles, I already know that these triangles are definitely congruent because I have side, 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 SSS. So if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So you definitely want to write down this postulate. So pause the video and make sure you copy side, side, side postulate into your notebook. So on a test or a quiz, you may be asked to use side, side, side to explain why two triangles are congruent, to really kind of prove or show how they are congruent. So I need to use side to side to prove that ABC is congruent to CDA. So ABC is the triangle on the right, congruent to CDA. I'm actually going to break these apart right now and redraw them. So I drew my two triangles to actually match. So if you look what I did here, get my arrow out. I took triangle ABC and I kind of rotated it so B was at the top. So AB with one congruent line is on the left, and BC with two congruent lines is on the right. So I redrew this triangle right here, and I put one congruent mark on the left and two on the right, so it matched. And I looked at this. CD was the one with the one congruent mark, so I've labeled this CD. And then in between, for the two congruent marks, was DA, so DA has two congruent marks. So I just kind of redrew this so I could look at it differently. You don't have to do this every time, but it might help you. It might help you to also see if the third side is congruent. So in order to use SSS, I have to prove all three sides are congruent. I already know that AB is congruent to CD because they have one tick mark. I know that BC is congruent to BC is congruent to DA because those have two congruent marks. And notice I'm marking it with a line segment as well. And then I need to see about the third side. Well, AC and CA, if you look, they were actually the same line. If you look up here, AC, let me highlight it instead, that's bad. Oops. AC is AC or CA. They're the same exact line. So these pieces were the same line. It's shared. It's actually called the reflexive property of congruence. But that proves to us that AC is congruent to AC or CA because they're the same line. So I want you to write down reflexive property of congruence. It's when the same thing is equal to the same thing. If you want to pause this video and maybe draw out the original image and the three sides that were equal to each other, feel free to do that. But now we know, since all three sides are congruent, that these triangles are congruent because of SSS. Side, side, side. All three sides are congruent. Another postulate that you can use to prove that triangles are congruent without showing that every side and every angle is congruent is called side, angle, side. We call it SAS. Side, angle, side. What that means is that one side has to be congruent to another. An included angle, which is So that's the wording, included angle, which is in between the two congruent sides. And then your other congruent side, it's kind of like a sandwich. You've got a congruent side with an angle squished in between and another congruent side. Okay, and if that's the case, then it's side, angle, side. And so we can prove that these two triangles are congruent because they have one side congruent to the other side, the included angle congruent, and the other side congruent to another side. Pause this video and copy down this postulate. At this point, you should have two postulates in your notes, and you should have the last example. Okay, here's another example. So we're trying to see if these two triangles are congruent, triangle ABC being congruent to triangle DBC. And we have to see if we can use SAS to explain that. So let's see what's given to us already. We have one side congruent to another side. We might have an included angle. We have an in-between, which would mean that this side has to be congruent to this side, so that it can be side, included angle, side, side, angle, side, and then side, angle, side. If we have that side, angle, side, then these triangles are congruent. But I have to just state if this BC would be congruent to BC. We know that BC is congruent to BC because they're the same exact line, and the reasoning of that, BC is congruent to BC, again, because of the reflexive property of congruence. You will see how much that comes up. Reflexive property of congruence is when the same line is congruent to itself, or the same angle is congruent to itself. So now we have SAS. We have a side, which is, let's write it out, BA. BA is congruent to side BD. We have the BC congruent to BC that we already showed. And then we have angle B congruent to angle B, but we can't call those angle B because they're broken up. So we have to call it angle ABC is congruent to angle CBD, with B being in the middle each time, because I'm really saying that those angles are the same. They're congruent. Let's look at these problems to see if the triangles are congruent. So in this first triangle, I have a side and an angle. I need to see if I have another side that might be congruent. Remember, this has to be the included angle, so it would have to be this side, so that it's side, angle, side. Here I have side, angle. I need this side congruent, but this is a shared side. It's the same exact side. So since these sides are congruent by the reflexive property of congruence, then these triangles are congruent by side, angle, side. Let's take a look at number 2. If you want to pause the video and think about it first and see if you know, you can do that. But let's look at it. So we have a side and an angle. Here I have a side, but I don't have an angle right next to it anywhere. So this can't be side, angle, side, because I need that sandwiched angle. There's an angle over here, but it's not like side, angle, or side, angle. It has to be right next to it. It has to be sandwiched in between. So this is not side, angle, side, and it's not side, 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 because I only have one side. I'd need all three. So we do not know that these are congruent. Our next problem. I have a side and an angle, so I would need this side, so it would be side, angle, side. And here I have a side and an angle, so I need this side. Well, this is the same side again. It's a shared side. So because of the reflexive property of congruence, these two sides are congruent to each other, and so the triangles are congruent by side, angle, side. And the last one, we have side, angle, side. Right here, side, angle, side. In this one we have side, angle, but we have no side here. And I have side, side, but no angle there. So number 4 is not congruent by side, angle, side. And it's not congruent by side, side, side. If I had that this was congruent to that, then I could say side, side, side. But as of right now, that's not the case. So I can't say side, 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 because those are not congruent. In this type of problem, it's asking us to show that the triangles are congruent for the given value of the variable. So they're telling me that x is 3. It's right here. X equals 3. So I would plug in 3. So this x is going to be 3. 3 minus 1 is 2. And here, 3 times 3 is 9 minus 5 is 4. So I have a 2, 3, 4 triangle. And on the left, I have a 2, 3, 4 triangle. So the 2 is congruent to the 2. The 3, I'll put 2 tick marks for that one, is congruent to the 3. And the 4, I'll give that 3 tick marks, is congruent to the 4. And so these two triangles are congruent. And it's my options now are SAS or SSS. Since I have 3 sides congruent, it's SSS. Here's another problem just like that. So this time they're telling me that y is 7. And so I would plug that in. So 7 times 2 is 14 plus 1 is 15. Right here, 12 times 7 is 77, 84. 84 plus 42 is 126. And on the left, 7 squared is 49. 49 minus 28 plus 3 is 24. And so now I have 15 for side length, 24 for side length, and an angle of 126, which matches exactly to what we have here. Those all match, and so that's side, angle, side. It's an included angle and 2 congruent sides. So those two triangles are congruent by side, angle, side.